Hello viewers, 4DIYers here, back with another tutorial video for everyone. In this particular video here, I'll be showing you how to install tool holders in your vehicle. This can include anything from a flashlight, shovel, fire extinguisher, axe, snow brush, wheel wrench, pry bar, or in my case a Johnson bar. I like to carry around a Johnson bar as it can get more leverage than compared to a wheel wrench, and some factory wheel wrenches can even bend with too much leverage. After some extensive searching online, I found these quickfist rubber clamps. I'll include the link to these in the video description. They come in a variety of sizes based on the diameter of whatever you're holding. I'll be installing these in my 2006 Dodge Ram regular cab. While I had the storage tray out of the truck for the audio system, I figured it was a great time to install this. I wanted this installed down low, out of the way, and somewhat hidden. These clamps can be installed on any panel, just make sure there's enough room for the tool it's holding and it's not interfering with anything else. These clamps should be installed on a flat surface as well. Not all panels are rigid enough to hold the clamps. The panel I'm working on is fairly flexible, and this is something I'll show you how to overcome. First is removing the panel. It's best to do this to see what's in behind so you're not drilling into any wires or mechanical components. I unbolted the armrest, which gave me a little extra movement. Specifically for the Dodge Ram, it has two T45 Torx bolts, one on each side. Once out, the tray is held in with three T25 Torx screws, then it can be lifted out. Behind the panel, there isn't any components where I'll have to worry about any interference with. The only aspect I'll need to work around is the ribs on the back side used to strengthen up the panel. While I could cut the ribs out, I'm mounting it up higher so it can be difficult to do, and it would also involve removing some of the rigidity of the panel. Instead, I'll cut plates to fit in between these ribs. The tray gets installed so I can figure out exactly where the clamps get mounted. Using tape, this will allow me to rough out the areas. I'll need to work around the seat when it's fully pushed back. It was hard to see in place, but once it's out, here's the rough location. I could very well use bolts with large washers and nuts on the back side, however I'd rather have a little more rigidity. Instead, I'll be using a larger plate on the back side. It's thick enough where I can thread the holes, so there's no need for any nuts and washers. I had a piece of stainless steel flat plate kicking around which I can put to use now. The plate will fit between the ribs on the back side. The section towards the center is narrower, so the length of the plate will be cut to almost the exact size here. The remaining portion will be put on the opposite side. The ribs on the plastic tray are perpendicular with the bottom. I reference this with a square. The piece is about 7.5 inches in length, 2 inches wide, and 3/16 thick. The first cut piece was about 3.5 inches. The remaining 4 inches will be put behind the other piece. Everything was marked out with a scriber. Ideally, I would have liked to use one continuous piece in the back, but the ribs do not allow for this. Instead of stainless, aluminum would also be a good option. However, you may want to go slightly thicker instead, so there's more strength with threads as it's a softer material. With aluminum or stainless, it can be kept as a raw material so you don't have to worry about rusting. Using an angle grinder, cut the piece to length and square up the ends if needed. For squaring up the ends and removing any burrs, a flap wheel is recommended. After that, I finished up the edges with a file for a cleaner finish. Now for marking out those holes. A marker is great for going over the surface so you can easily see your scriber lines. If you make a mistake, the area can be touched up with a marker and remarked. A caliper is used to determine the hole locations along with how close I'll make the clamps to the edge. I'm not making the mount centered on these plates as I want the clamps further apart to securely hold the Johnson bar as it's longer. With heavier, longer items, it's best to have the clamps further apart, otherwise the tool may rattle around. For determining the dimensions of the holes, this company didn't have anything posted online from what I could find. Align the caliper jaws with the same edge of the hole. This can be both right sides or both left sides. As long as you're measuring the same edge, this is the same as the center line, yet it's easier to reference. Everything gets written out on paper, so I can transfer it over to the plate after. Depending on the size of your clamps or if you're using a different style, these dimensions may vary. I already have the one marked out, and then is marking out the second one. Triple checking my measurements just to be safe. Once a hole is drilled, you can't go back. I even put the clamps in place for verification. The lines are then marked out lightly with a caliper, then finished up with a scriber and square. To keep the holes accurate, a center punch is used. This along with a center drill will keep everything in place. Here's a close-up of the layout. Before I get into drilling, first is my fastener choice. I have everything nicely organized in my OEM Tools 22186 parts containers. They come in a 3-piece set and are perfect for any type of fastener, however they're not just limited to nuts and bolts. My fastener of choice is a black oxide button head socket screw. This is a 1032 thread. The length of the fastener will depend on what it's going through. If you have some fasteners laying around and are unsure of the type of thread, I have both metric and SAE tap and die sets. These sets will typically come with a thread gauge. This is used to determine the profile of the threads and will help me reference the tap or die. It's always nice to have a nut or bolt to go along with the fastener, as you can verify the tap or die. Once you found the right thread gauge, it'll have a number stamped on the side. In this case, it's 32. Using a die, look for the appropriate size 32 type thread. In this situation, the proper die would be a 1032. Look for the corresponding tap, and this can be verified using the nut that matches a screw. It's hard to see on camera here. Taps will typically have a size printed on the side, either by etching or stamped. The etched versions can be sometimes hard to see and will eventually wear off. Considering this is a tap that wasn't included in the original set, the supplied chart doesn't work. So I have an alternative version instead. This is a tap and drill index. Based on the tap size, it'll specify a required drill size. Being that this is an SAE size, if you don't have the right SAE drill, it'll provide an alternative in metric if you have them. This requires a number 25 drill. An alternative would be a 4.10mm. I don't have a 4.10 drill bit, but I do have a 4mm, which should be fine. It's better to go a size smaller than larger, otherwise you'll lose the thread profile and have a loose fit. A loose fit means it's not as strong. To keep everything as accurate as possible, the holes and tapping will be done in the drill press. The piece gets aligned with the center drill bit, then clamped into place so it doesn't move. Apply some cutting oil and then use the center drill. Center drills are more rigid than compared to a smaller drill bit, so you don't have to worry about them wandering, flex, and there's minimal risk of breaking. This is only used to get the spot started, so a larger drill bit doesn't wander. Install a proper sized bit, apply more cutting oil, and then drill it out to the appropriate size. Take your time so it's not overheating the bit, and apply more oil if needed. Clean away any chips when done and install the tap into the chuck. Some people do power drill on a drill press, however I do prefer a safer route, doing this by hand. Tapping on a drill press keeps the tap parallel with the hole. Apply cutting oil to the tap and hole. Light downward pressure so the tap isn't pulling the chuck down, and rotate the chuck by hand. You may be required to back it off slightly after a couple turns to clean up the cutting. Do this if you do feel any resistance, otherwise you can break the tap. Apply more cutting oil if needed. You'll feel it right away when the threads are fully cut. Hold the chuck in place, loosen the chuck, allow it to retract back, and back out the tap by hand. Do this for the rest of the holes. Here's another view on how I tap the holes. Take your time when tapping. This can also be done by hand, and a nut can be used to hold the tap in place to keep it parallel with the hole. If you're having a tough time removing the tap, sometimes the chips can cause binding, so clean them away from the back side. Finally is marking out the fifth hole. This is the one in the center. To mark out this hole, I'll be using a transfer punch. This is the same size as the hole, so it'll have a tight fit and it will mark the center. Bolt the clamp into place. Using the transfer punch, mark out the hole. This hole isn't perfectly centered, its vertical alignment is slightly off. Be mindful of this on your backing plates if they have a specific orientation. These I can flip around so it's not a problem. The center holes get drilled and tapped just like the others. From drilling and tapping, a burr can sometimes be left behind. A significantly larger drill bit can be used for deburring. Just do this by hand, turning it around the hole to remove any material. Now is marking out the holes on the plastic tray. Apply tape first. Taking the measurements from the rough location, this will give me the vertical height. It's the same for both sides to keep the bar parallel with the top. The ribs are referenced, ensuring they are square with the bottom edge. They're marked over to the outside so they don't end up on top. Do this for both. You can never have too many reference points, which helps avoid any mistakes. The vertical position is then marked out. And finally is using a level as a straight edge to make it a reference line across the top for the brackets. The holes are then traced out over the tape. Place the brackets in the same orientation as they would be installed, so the side facing me would be against the plastic when installed. Drill the holes. You can go with something slightly larger to reduce the chance of any interference. Using my OEM Tools 24487 20-volt lithium-ion brushless impact driver, if you have the right style drill bits, this makes any job requiring drilling of holes a breeze. Depending on your interior components, don't push the drill bit in too far where it can damage the surface in behind. In this situation, the storage tray is in behind, and yes, it's possible to drill through the inner wall. And finally, remove the tape. You may be left with some burring around the plastic. Again, use a larger drill bit to clean these up by hand. Only do this by hand as you have control over the bit, and you don't risk drilling a larger hole. The brackets were cleaned up using 400, 600, and 1000 grit Scotch-Brite. This will give them a satin finish. While they are hidden, it's nice to know it has a clean finish in behind. Here are the brackets after they're cleaned. And they get installed like this. The holes were cleaned up to remove any cutting oil using a wax and grease remover. Brake cleaner can also be used. The brackets are only rubber, so they can't be excessively tight. Therefore, there is a risk of the screws backing out. In order to prevent this, a medium-grade thread locker is used. If a thread locker is applied to the screws, it may rub off into the brackets, so I applied it to the threaded holes instead. Now the brackets get installed. I'm not installing the washers on the outside, as this would be too large, extending it past the bracket's edge, not allowing for a clean finish. Start all the screws in by hand first so everything is aligned, then finish up tightening everything down. As mentioned earlier, these brackets are only rubber, so don't over-tighten them. Here's a close-up of the brackets. As you can see, there is no flex around the brackets, but instead further on the plastic tray. Once that Johnson bar is installed, the rubber clamps have a variety of slots for the diameter adjustments, and they'll keep any tool securely in place. Install the tray back into the truck. The Johnson bar is easily accessible and hidden well behind the seat. The black screws allows for a clean, subtle finish. Black oxide finishes can rust when exposed to weather, so they're not suitable for exterior use. The rubber brackets won't scratch any tools they're holding onto, and I won't have to worry about any rattling noises. As you can see, it doesn't interfere with the position of the seat either, and I can still maintain storage under the seat. I may install some type of storage tray under the seat as well. That'll be something safe for the future. New videos are released every week on my channel. Be sure to hit that thumbs up button. It's a huge help to me, and leave a comment below if you found this tutorial helpful. If you're not a subscriber, be sure to also hit that subscribe button. Thank you for watching.